Okay, so today we're going to have a look at a sample calculation for the bleach experiment that you wrote up yesterday. Okay, and this is on page 232 and example 15.8. So the first thing here I'm told is that 25 centimetres cubed of the household bleach is diluted to 250 centimetres cubed. I'm going to come back to that dilution at the end. I'm told then a 25.0 centimetres cubed of the solution, which is my household bleach solution, is added to an excess of potassium iodide solution and titrated against 0.12 molar sodium thiosulfate solution previously standardised, which we did in the first experiment. The average titration figure was 32.1 centimetres cubed, and we are asked to calculate the percentage sodium hypochlorite in the diluted bleach firstly, and then in the original bleach in moles per litre, grams per litre and percentage weight per volume. We're given the two equations and these are my two equations. So what I'm just going to do first is I'm going to write down underneath each of these what I have. So firstly I'm told at 25 centimetres cubed of sodium hypochlorite. ClO minus is the hypochlorite ion, okay, and the Na, the sodium part, doesn't take part in the reaction, so that's where my sodium hypochlorite is. And I'm told that it was titrated against a 0.12 molar sodium thiosulfate solution, and my average titration figure is 31.1 centimetres cubed. And I'm given my equations here, okay? So what I'm going to have to do first is I'm going to have to work out my ratio. So again here, if we look at my last experiment, my iodine again acts as my link. So I have my ratio, ClO minus is to I2, and then I have I2 is to S2O3 2 minus. ClO minus, ratio here, 1 is to 1. And ratio here, 1 is to 2. So because my I2s are the same, they can immediately cancel out. So my ratio is a lot easier here, simply 1 is to 2. Then I start here with my 0.12. That means I have 0.12 moles per litre, which is in 1,000 centimetres cubed. But in this question, I haven't used 1,000 centimetres cubed. I've only used 32.1. So I multiply by what I know and I divide by the bit left over. And that gives me an answer here of 3.852 by 10. It's the minus 3 moles. That is my moles of sodium thiosulfate, but in the question I'm asked for it in relation to my sodium hypochlorite. So ClO minus is to S2O3 2 minus. My ratio here is 1 is to 2. And I've worked out my concentration of sodium thiosulfate is 3.852 by 10 to the minus 3 moles. So again, multiply by what I know. Divide by the bit left over, so I multiply by 1 and divide by 2, and that gives me a concentration of 1.926 by 10 to the minus 3 moles. Now, in the question, I'm asked for diluted bleach and I'm asked for original bleach in moles per litre. This is 1.926 by 10 to the minus 3 moles. But that's only in 25 centimetres cubed. So in order to get that into moles per litre, that's 1,000 centimetres cubed, I have to multiply by what I know, which is 1,000, and I divide by the bit left over, which is 25, and that gives me 0.07704 moles. Now, I am asked for my moles per litre in diluted bleach and also in original bleach. So it's very important that you write down what the question is actually asking you. When I look at my diluted bleach, I've worked that out from my previous answer. That's 0.007 moles per litre. Now, In my original bleach, I was told that I diluted it from 25 to 250 centimeters cubed. So I've diluted it 10 times. So in my original solution then, I'm going to have that by 10. And that's going to give me 0.7704 moles per litre. Okay? And that is my answer to A. This is my answer to part I. And this is my answer to part II. So please make sure you are clear on which one is which. The next then we're asked is to find out, again, my diluted bleach in grams per litre. I'm going to use number of moles equals mass in grams divided by my relative molecular mass. And it is my relative molecular mass of NaClO. That would always be given to you in a question, even though it wasn't here. Na is 23, chlorine is 35.5. Don't forget the 0.5. Remember, it's one of the only ones that we don't round up or down, along with copper. And that gives me 74.5. Now, again, I am asked for my mass in grams in diluted bleach in this question. So in order to get my number of moles, I have to use my number of moles for diluted bleach, 0.074. And I multiply that by its relative molecular mass. And that's going to give me 5.7395 grams per litre. That's in my diluted bleach. Again, though, I'm asked for it in original bleach as well. So for my original bleach, I have to use my number of moles in original bleach. So 0.7704, and then we multiply that by 74.5. So 0.7704 by 74.5, and that gives me 57.395. If you wanted, you could also just multiply this by 10, because that is also your dilution factor. So either way there is fine. And finally then, again, we're asked for it in percentage weight per volume. Okay, so percentage weight per volume means, so again we look here at my diluted bleach, means grams per 100 centimeters cubed. I have worked out it's grams in 1,000 centimeters cubed for my diluted bleach is 5.7395. So I multiply by what I know and I divide by the bit left over. Okay, again here you can just pretty much divide by 10 because that is essentially what you're doing. And that is going to give me 0.57395 or 0.57395 percentage weight per volume. And then in my original bleach, my percentage weight per volume is going to be 57.395 grams per litre, which is 1,000 centimeters cubed. Percentage weight, anything percentage is always out of 100. So multiply 57.395 by 100, and I divide that by 1,000, and that gives me an answer of 5.7395 grams or 5.7395 percentage weight per volume. Again, you could have done that just by multiplying this by 10 because that is also your dilution factor. And that is how you do that when you're asked. Now, you may not all the time be asked for both, but in this question you were. So just make sure to read the question and to answer the question you are asked.